Assalamualaikum. My name is AHMAD FAKHRUL ARIF bin Muhammad YUSRE, section 1/1 BEI. So today I want to answer and solve this question. Question 4 from past year paper from year 2021/2022. So first question in question 4 is about transient response. So let's go to the question. So this is the first question in question 4. So if you see, you can see the equation. The question is asked the output yt of open loop system is given by following equation where the input rt is unit step ut. So this is the equation, and if you see the equation, this is a T domain equation. T domain. So from this T domain, we need to change to S domain to find poles and determine the type of the system response. Okay, so I will show you how to change this to S domain. So first of all, you need to do is Laplace transform. So from this equation, we do Laplace. 1 is equal to ut, masuk balik ke dalam, and e negative 2t cos 3t u 3t dalam ut Okay, so after we do that, and then from the Laplace transform table, we can find that ut is 1 over s, and then e negative 2t cos 3t is equal to s plus 3 power 2 plus 3 over 2. And then we kembangkan S3 to S2 plus 6S tambah 9 plus 9, and then it will be S over S plus S3 S kuasa 2 tambah 6S tambah 18, and then we minus the equation, so it will turn out to be like S kedua 6S tambah 18. Ni tolak S kuasa 2 tolak 3S. Okay, so this is the S domain of the equation. So we need to check the Laplace transform table to solve this equation. Okay, so move on to the next question, which is find the poles and determine the type of the system response. Okay, so next question. So how to find poles? Poles we can find by using the denominator from the equation. This one. This is the denominator. We use this one to find the poles. So this is a quadratic equation. We can solve this by using calculator or using formula. So this, if we tekan calculator, it will be s plus 3, s plus 3. So s plus 3, and then poles. First poles is 0 because the equation before s equal to 0, and then this one S sama dengan negatif 3 minus plus minus 3J. So from this poles we can plot the poles. So this is imaginary axis, and this is real axis. So first of all, S equal to 0, so this is 0, and then negative 3 plus minus 3J. So this one is negative 3, this one is negative 3, and then 3 plus 3J minus 3J. This one is 3, this one is negative 3. So this is negative 3J. Negative 3J. This one positive 3J. Okay, that's how we plot the poles. And then untuk determine the types of the system response, system response have four types of system response. First is under dam, the dam. Second is undam. Third is critically dam. Critically dam. Wait. Critically dam. And then last one is over dam. So under dam, to know which is the under dam, undam or critically dam or over dam, by using the damping ratio. For under dam, the damping ratio must be higher than 0 but lesser than 1, and then under dam will be the damping ratio is the same as 0. Critically dam, the damping ratio equal to 1, and then over dam, the damping ratio over than 1. Okay, so this is how you determine the type of the system response. So from this equation we can find out the damping ratio by using the denominator. For the 6S is equal to 2 damping ratio Wn. So from this equation we can get 6 over 2, and so 6 over 2. Oh, before that we need to find Wn first. So how to find Ws is easy. 18, just alihkan power of 2, so jadi macam tu, and then we get 4.243. Then we put Wn 4.243, and then we will get 0.707. Okay, so this is the damping ratio. Damping ratio is 0.707. So because of that we can conclude that the system response is under dam, because the damping ratio is lesser than 1 but above than 0. So the type of the system response is under dam. Okay, next question is to find time peak. Time peak, this is the formula we need to remember, and then we just fill the formula. Pi Wn is this one. We already find this 4.243, then pi 1 tolak 707 2, and then the answer will be pi over 3, and then equal to 0.4 0.47 1.047. Then the next one is percent overshoot. It's easy, just fill the blank. Exponent negative 0.7070 pi divided by 1 minus 0.7007 kuasa 2, and times by 100. So we get exponent negative 3.141 times by 100. Okay, so we will get 4.321 4.321, and then time settling, just fill in the question. 4 over damping ratio is 0.70 0.707 times by 4.243. Then the answer is 1.33. Okay, that's how we find the time settling, overshoot, time peak, and from the question. So that's it for the first question, and then we move on to the next question, question B. Question B is using the block diagram. Block diagram for a closed loop control system is shown is question 4 for B. Using block reduction method, highlight this one. We need to use BRM method. Find the final closed loop transformation. Okay, so this one. So this is the block diagram. Okay, so I already solve the block diagram a little bit, and then we just need to fill in the blank. So first thing, from the block diagram, we have G2S, G2S, and then if ada block yang selari in series, if a block is in series condition, we just need to times it. So G2 and G4, so this one, G2 and G4 is in series. So if the series, kita boleh darab je. So darab series, and then it will change 3G S darab dia G4 S. So So kita masukkan dia kat dalam ni. So G2S kat atas, and then bawah dia G3F and G4S. Okay, and then the last one is the feedback is H plus HS. Okay, so from this block we can make it to this block by looking at these two block. These two is parallel. If it's parallel, the formula is plus, is the sum. So G2F plus G3F G4S, and then stay the HS, sebabkan dia parallel. If you parallel, nak matikan parallel dia, we need to plus. The formula is plus, parallel plus. Kalau series, darab. Okay, so after that we only have 2 more blocks. So if feedback loop, the formula is G. So this, and then this feedback loop, then this turn out to be like this. G2F plus G3F G4F divided by 1 plus G2F plus G2F HS plus G3F G4F HS. And then after that we go to the final block reduction. We need to combine these two blocks and then by times multiply it. So just multiply it. So first G1F G2F plus G3F, and then just salin balik. This one G1, sorry, G1F G3F G4S, and then by just salin balik 1 over G2F HS plus G3S G4S HS. So the answer will be like this. Okay, we go on to the next question. The last question, which is draw a final flow. Find the final closed transfer function by using Mason rule. So we need to use Mason rule to find out the transfer function. So this I already write the answer, the solution, and then we just go through. Okay, so first thing we need to do is forward path. How to find a forward path? Forward path is the path is a straight path from RF to CS. So how I get the M1? First M1 is G1, G3 and G4. So this is, I use this color. So this is G1, G3, G4, G3, G4, and then times by 1, 1, 1. So this is the first forward path, M1. The second one is M2, G1 and G2. So the second one is this G1, and then we go this G2, G2, then times by 1, 1, and then this is another second forward path. We try to find another forward path so there is no other forward path. It's only two. Next one we need to find is loop gain. So loop gain, how to find a loop gain? Loop gain is a path that is satu bulatan lah, bulatan jalan. Look at the first one, loop gain 1, negative G3, G4 and HS. So G3, G4 and HS, this one, G3, G3, G4 and negative HS. So dia datang balik, that means this is a loop gain. This is a loop gain 1. And then another one is loop gain 2, G2, negative G2 and HS. So negative G2 is here. And then this negative HS. The times by 1, times by another 1. So this is loop gain 2. Loop gain 2. Loop gain 1. And then we sum of the loop gain. Just plus all of the loop gain. And then to non-touching loop gain. So in this signal flow graph, we cannot find the two non-touching loop gain. Because the two non-touching loop gain is jika ada satu loop gain 1 dan loop gain 2 yang tak bersentuhan. Itu dipanggil two non-touching loop gain. If ada 2 loop gain yang tak bersentuhan. If lah, contohlah this one ada loop gain kat sini. This one ada loop gain, and then this one is loop gain. So this one dengan ni tak bersentuhan. That means ini dikira two non-touching loop gain. But in this question, tak ada. There's no two non-touching loop gain. Okay. So we move on. So we move on to the next step, which is determinant. Determinant, we need to remember the formula. This is the formula. Determinant equal to 1 minus sum of loop gain plus sum of two non-touching loop gain. So this is formula we need to remember. So the sum of loop gain, ambil dekat sini. This is sum of loop gain. And then plus two non-touching loop gain. So two non-touching loop gain is 0. So plus 0. So tak ada lah, kosong lah. And then we go on to the next step, which is coefficient. Coefficient We need to remember the formula first. 1 sama dengan 1 minus sum of non-touching loop M. This mean non-touching loop forward path. Macam mana nak jumpa non-touching loop forward path ni? Non-touching loop forward path ni kita kena tengok dua benda, iaitu forward path kat sini dengan loop gain. Forward path dengan loop gain. So nak tengok dia macam mana. So if lah satu forward path ni, contohlah M1, forward path M1 ni, dengan loop gain 1 tak bersentuhan, itu dikira non-touching loop forward path. Tapi dalam soalan ni semua forward path bersentuhan dengan loop gain. Contoh forward path pertama M1 yang ni, yang straight ni, straight ni bersentuhan dengan loop gain 1 yang hijau ni dengan loop gain 2. So dia bersentuhan. So dia kira tak ada lah, kosong lah. So contohlah kalau tak bersentuhan, I mean if lah satu ni, if atas ni straight forward path, and then kat tengah ni ada loop gain 1 kat tengah ni. Yang ada 2 node ni, contoh 2 node ni kat sini, 2 node ni kat sini, and then sini ada loop gain. Ni tak bersentuhan dengan forward path yang pertama tu, and then kita boleh include non-touching loop forward path. Tapi semua dalam ni bersentuhan dengan loop gain, so kita tak boleh terima benda tu. So we go to this formula. Coefficient nak dapatkan dia, coefficient forward path ada berapa? Forward path ada 2, M1 dengan M2. So kita kena cari 2 coefficient. So coefficient 1 tolak non-touching forward path, 1 tolak kosong ni sebab tak ada, and then sama dengan 1 dia sama dengan 1. So after that we just masukkan balik. So M1 coefficient 1. So M1 kita first G1 F, G3 F, G4 F. Darab dengan coefficient 1 kita. Coefficient 1 kita adalah 1. So darab dengan 1 sama dengan ni. So we go to the next step, plus M2 forward path second G1 F, G2 S. G2S. So over by ni adalah determinant yang kita dapat tadi. Ni determinant dia. So jumlah determinant kita 1 plus G3 F, G4 F, H S tolak G2 F H over HS. So this is jawapan dia. So nak tahu kita punya jawapan ni betul ke tak, we can look to question before. So question before kita buat block reduction method. So if lah block reduction method kita dengan signal dengan Mason rule kita jawapannya sama, maknanya jawapan anda betul. So kita tengok balik So G1, G3 S, G4 S, G1, G2. So tengok balik G1, G2. Tak apa, susunan terbalik tak apa. Yang penting dia punya ni betul. G1, G2, G1, G3, G4. 1 plus G2 HS, G3, G4 HS. G plus G3, G4 HS, G2 dengan HS. G2 dengan HS. So dua-dua ni sama, so that mean dia betul. So the formula ni negatif. 1 tolak negatif sum of loop gain. Tapi ni jadi positif sebabkan kita punya loop gain kita adalah negatif. So negatif jadi positif. Okay, so that's all saya punya penerangan how to solve the question. Alright, so thank you.